Hi everyone. Today's lesson is constant acceleration, and we're talking about how we get the four formulas. First, the left side graph, this one, is a right side graph, VT graph. What's the V? V is velocity, and T is time. And first, well, what's the acceleration for this ball? Yeah, this ball. So this ball is drop to here, and the velocity is become bigger and bigger. So what's the constant? The bigger and bigger is the acceleration, 加速度. And this acceleration equals this slope, this graph slope, this one. And it is equal to Vt minus V1 over T. V2 is the final velocity, and V1 is the initial velocity. Then we can get this one. V2 equals V1 plus AT. And this is the first formula. We can get the relation between the velocity and time when we have a constant A. 我们有一个稳定的一个恒定的加速度的时候，我们可以有这条式子。And second, delta x equal to v1t plus 1 over 2 at squared. How can we get it? It's very easy. We can easy to know the area, delta x. What is delta x? Delta x is the distance we go, like a ball. And what's a ball distance when it falls for a time t? And we know the trapezoid formula is v1 plus v2 over 2 times t. But sometimes we don't know what is v2, so we put the formula 1 v2 equals v1 plus at inside this v2. Yeah, we can see here. Then we can get delta x equal to v1t plus 1 over 2 at squared. So we can get the relation between delta x and time when we have a constant a. And third, v2 squared equals v1 squared plus 2a delta x. And how about there is not any time? We have the time in the past formula 1 and formula 2. But there is no t now. So we put the formula 1 to formula 2. It changes the t. So you can see lots of paths. Then we get the v2 squared minus v1 squared equals to 2 times acceleration times delta x, the distance. So we can get the relation between displacement, delta x, and velocity v. Also, when we have a constant a. Then the fourth one, this is the most easy one. The average v equals v1 plus v2 over 2. It's very easy to see. It's just a half. Okay, now we talk about some basic knowledge. And when you're near the Earth's surface, 就是你在近地的时候, it means you're on the ground, not too high, not in the ground, on the ground, okay, on the ground. Then the acceleration a equals g, and g is for the gravity, and it is constant. And what's a g? G equals 9.8 for 9.8 meters per second squared, and it is for the Earth. So if you go to the moon or you go to Mars, the acceleration might not be 9.8. If you go to the moon, the number you must divide it to 6. If you go to the Mars is smaller than Earth. The mass is smaller than Earth, so it might be a little bit smaller than Earth. Okay, this is the basic knowledge. 这是最基本知识。So just like a ball, you put a ball, let it free fall, and you can see, its velocity is bigger and bigger. It's constant bigger and bigger. 它的稳定的上升。Okay, let's do some example. The ball, like this graph. We now have its high, and let the ball get free fall. What's the time the ball need to drop to the land? We use formula 2. Delta x equals v1t plus 1 over 2 at squared. And we know delta x equals high, h. And we have no initial speed, so v1t equals 0. And a equals g, because you are on the Earth's ground. So it's very easy to get the high equals 1 over 2 times g times t squared. Then you can get t equals 2g over high root. Then, what's the final velocity for the ball? Then we use formula 3. v2 squared equals v1 squared plus 2a delta x. v1 squared equals 0 because v1 equals 0. It's easy. And a equals g, and delta x is h. So we get v2 equals root 2gh.